Okay, so let's discuss some other measures of the quality of your project. Um, and the first is the Profitability Index. And that's just the present value of revenue divided by the present value of investments slash expenses. They mean obviously the same thing. Okay, so this is fairly plug and chug, and of course this is at some some interest rate, and so if you just multiply top and bottom by 1 plus j to the n, where j is our interest rate per period for the cash flow, and n is how long the cash flow lasts, then it's the same thing as taking the ratio of the future value of revenue and investments. Okay. So yeah, this is fairly plug and chug. I'll explain what the benefits and downfalls of this is. So let's just do a simple example. So you have two projects that require initial investment of 1,000. Project 1 generates 250 at the end of each year for 5 years, starting at the end of the first year. And Project 2 generates 140 at the end of each year, for 10 years starting at the end of the first year. Find the profitability index at 5%. Okay, so yeah, like I said, this is pretty much plug and chug. Not a whole lot to the calculations involved here. So this is project 1, minus 1,000 initial investment. And then you get the revenue of 250 for 5 years after that. So the present value of revenue is just an annuity immediate for 5 years at 5% is 1082.4. And then you have just the present value of expenses. Well, it's just 1,000. That's just their, it's just their initial expense is 1,000. Initial investment, same thing. So it's 1.0824. And on the other hand, project 10 is basically the same thing, similar rather. You got 10 payments of 140. It's the revenue. So the present value of that is 14810.05. Again, it's a annuity immediate because there is no revenue of 140 at the beginning of this project. And again, the present value of expenses is just 1,000. So this is 1.081. Okay. All right. So what is the purpose of the profitability index? Why is it useful? Well, it tells you by definition your return per dollar investment. So for example, in project 1, so PI subscript 1 is for the profitability, index for project 1. That was 1.0824, and that's the present value of revenue over the present value of investments. So multiplied by the present value of investments, that tells us that it tells us what your revenue is per dollar investment. And of course, that's if we don't change our cash flow all that much. If you do change your cash flow a lot, then obviously your profitability index is going to change. So as long as you don't change your cash flow all that much, the profitability index tells you your return per dollar investment, which is quite useful to know, obviously. Well, the downfall of it is that it's just a ratio. It doesn't really, it doesn't tell you how much the present value of revenues actually differs from the present value of expenses. Okay. And well, net present value does actually just that, if you think about it. Because remember, we had the formula for net present value, which is the formula to compute net present value was you take the present value of your cash flow. Okay? Well, really, taking the present value of the cash flow is the same thing as taking present value of revenue minus present value of expenses, because here we're thinking of expenses as positive, whereas when we take present value of the whole cash flow, we're thinking of expenses as negative. So it's literally the same thing. Okay. So what's interesting here is that if you take this into consideration, and in particular you divide, so remember what is the profitability index? Present value of revenue over present value of revenue over present value of expenses. So if you divide both sides by the present value of expenses, on the right-hand side, you would get profitability index -1. Okay. So just doing that, you get that net present value is positive if and only if, or rather precisely when profitability index is bigger than 1. Okay. And remember, what does net present value positive mean? It means relative to, our interpretation was relative to the default option of taking your expenses, foregoing the project, and just investing it at your given interest rate. So relative to that option, the net present value is the profit or the loss of your project. Okay. So relative to this default option of foregoing the project and just investing expenses, you have a profit precisely when your profitability index is positive. Sorry, not positive, bigger than 1. Okay. And for obvious reasons, you want to pick projects with the largest profitability index if possible. That really goes without say, because you want the most return for your dollar investment. Okay. Right. Okay, so let's talk about payback and payback periods and discounted payback periods. So for simplicity here, because in general you really can't compute these using your calculator, if you don't kind of look at just simplified, simple examples. So for these examples, let's assume our cash flow is an initial expense followed by, so you have some initial expenses followed by revenue. Okay. Usually it's just one initial expense followed by some revenue. Not always that way. Okay, so the payback period is just very simply the first instance where the cash flow makes a profit. Okay, and this is after your initial expenses. So after your initial expenses, after you get some revenue, when are you finally making a profit? Well, what's more important and more realistic, though unfortunately not always managers understand this, they should if they had any decent business sense. Sometimes they don't, unfortunately. What's more important is the first instance when you make a profit time value. Okay, because that's what's really most important. Obviously, no matter what, money is not money. Money today is not money in the future. It's generally speaking, you have inflation. Money that you spent could have been invested, so it's worth more in the future. Your expenses are accrue interest because you could have invested that. Okay, so what really the discount payback period is, I'll explain actually how to find that in a second. So let's find both for project 2 in the previous example. So remember, project 2 had this timeline here as follows. Okay, so for the payback period, there's not a whole hell of a lot to this. When are you going to make a profit? Well, when your 140 added up n times equals your expense. So you solve for n at 7.4. Well, that doesn't really count as your answer. So you need 7 years if t when So here, remember for project 2, T is in years. It's a 10-year project. So you need 8 years to finally return a profit. Okay. So what do you really want to know? You really want to know, when do you make a profit finally relative to foregoing the project and investing your $1,000 into an account earning some interest rate, with the assumption that when you make your 140, when you get that in, you're also investing in this account that you think this safe investment, or just this investment that you think you have. So let's set the situation up there. Okay. So in this example here, so here for the discounted payback period, let's use 5%. Okay. I'll explain why it's called the discounted payback period, even though it really makes more sense taking accumulated values, because we're asking when this makes a profit. Okay, so the default option here, let's see, this should not be, well, let's not play around. Zoom is not good with two things open at the same time. So, so let's take this $1,000 expense. Let's say we forego the project and just invest it at a rate of 5% effective annually. Okay. So what does that 1,000 accrue to? 1,001.05 to the end. We don't know how many periods of interest 1,000 is earning. Okay. Well, what does the revenue from this project accrue to if we take the 140 and also invest it at 5%? Well, we should know what the answer is. It's 140 N 0.05. Okay, well, that's all fine and dandy, and you can solve for N. Doing this, that's fine. Sorry, it's not A. Actually, write a lot on exams with exclamation marks when my students make this mistake. So I should scold myself somehow. I guess doing a video at 10:45 at night is scolding enough. So it's 140 SN 0.05. That's the accumulated value after investing the 140 after N periods, N years rather. And the 1,001.05 to the N is what the 1,000 would accumulate to after N years if we just forego the project and dump this 1,000 into an account earning 5%. So again, relative to that default option of just investing the 1,000, when do we make a profit? Okay, or when do we finally break even rather? Okay, so the easiest way to solve this is, and this is why it's called discounted payback period, is we divide both sides by 1.05 to the N. And we should know what happens to accumulated value when we divide by the growth factor to the N. We just get the present value of our annuity. Okay, so this says that this here, what I have here, is the same thing as saying 1,000 is the present value of your revenue after N years, and that's how we do this. So it's you know, we set really the equality we set is present value of expenses is going to be equal to present value of revenue after N periods. That's how we solve for the discounted payback period. Though we're really, I mean, in my opinion, what you really want to know, it's the same thing, but I think this is a much better interpretation of, looking at it like this perspective here of when finally, sorry, get rid of all this. When relative to this this default option of foregoing the project and just investing your $1,000 into an account earning 5%, do you break even, assuming you invest 140 into the same account, earning the same interest. Okay, right. So for discount, let's do exactly this. And you can either dump it into your calculator. That's by far the quickest way to do it. Clear TBM. So remember, you make your calculator unhappy if you don't enter minus 1,000, and it makes no damn sense if you enter plus 1,000 and you enter plus 140 for your payments. But anyway, minus 1,000 is the present value that I enter. Payment is 140. 5 is the interest rate. Compute. And then you get 8.2. So it's really the nearest integer is 9. So it's going to be 9 years. 1 second. What did I enter? 5 interest. Let me do that again. Not sure what I did wrong there. 5 interest, 1,000. Present value, 140. Payment. Compute. And let's try that one more time. 1,000. Present value, 140. Payment, 5 interest. Compute. And I don't know what I did wrong. Anyway, so right, you get the right answer, 9.056. Or if you don't want to use a calculator, you just divide by 140. You basically just solve for n. Just a little bit of algebra. You get 1.05 to the minus n. Is 0.64286. Then take ln of both sides, what we've done before, and you get 9.056. You would do 0.64286 ln. Make that minus, or make it plus, over parentheses 1.05 ln 9.0556. I'm going to try this one more time. See what on earth I did wrong. 1,000. Present value 140. Payment 5 interest. Compute n. I don't know. Doesn't matter. So okay. So yeah, the answer is 10 years because you need a concrete, you need a year. So really, it's after 10 years you're finally making a profit. In a sense that relative to your default option, after 9 years you don't make a profit. You're losing money relative to the default option. And for the payback period, after 7 years, you still haven't paid back your 1,000. It's only after 8 years that you did, that you're finally making profit. Okay, so hopefully that the practical meaning of discounted payback period made sense. Okay, so let's talk about MIRRs. What's a MIRR? Well, it's just an with an M, obviously. Silly question. No, it's called the modified internal rate of return. And I'll explain what that is in a second. And through this explanation, we'll go through yet another interpretation of the internal rate of return, which I think is interesting, that these concepts have all these different equally useful interpretations. So here's the situation. You have two separate interest rates for expenses and for revenue. What do I mean by that? Well, let's say you have a project. Perfect example is SUNY Albany building, the engineering building, the Schuyler building. Let's say you don't have money for the project and you have to borrow to get money for the project. Okay. Now, let's say to finance the project, to finance the expenses that you need in your cash flow, you want to invest right now. Okay. Now, realistically, you might want to invest conservatively, because if shit hits the fan, your project just completely goes south. And that's exactly what's happening with the Schuyler building. SUNY Albany does not have the money to make renovations to the Schuyler building so that they can actually bring the building up to code. Okay? And that's a big practical problem. I don't care how lucrative this project is, if you can't even get it off the ground, it's worthless. Okay? And even lucrative relative to your expenses. If you can't even afford the expenses to get the project off the ground, yeah, you're screwed. There's nothing you can do. It's a moot point how profitable your project is. Okay, and with that perspective, you might not have wanted to invest in the stock market in the past month because the volatility is absolutely insane in the past month. So now, that being said, if your project generates revenue for 20 years, sure, invest in the stock market, invest in the S&P 500, which I think historically gives you like a 6% rate of return per year. Yes, there's ups and downs year after year, but you know, if you're taking a long-term perspective, what you would consider conservative is a hell of a lot different than what you might consider conservative to finance the expenses involved, or at least say some of the initial expenses involved in the project to get the project going. Again, the Schuyler building is a perfect example. I mean, things are a little different there in the sense that what did SUNY Albany think? They thought that they would have, 20,000 students by 2020. Obviously, it didn't happen, so they didn't have the revenue that they expected. There's other things, they, for some bizarre reason, didn't think faculty should get raises. But anyway, so a little bit different, but it still drives the point home. Okay? That it's very practical to have a different interest rate for expenses, to finance your expenses, than you have for a revenue interest rate to actually reinvest your revenue. Okay? So a lot of times in accounting and finance, and this book also calls the expense interest rate your cost of capital or your financing rate. And a lot of times your revenue interest rate is your reinvestment rate, which makes sense. It is the rate that you're reinvesting at rather. I should mention, I don't like the books, how the book does modified internal rate of return. It just goes against every other finance and accounting, economics, whatever explanation I've ever seen. So, and it really doesn't make a whole lot of sense, I think. And if you go look it up in another book or online, you'll get this weird formula Well, the books, you get a formula that doesn't resemble what the book is doing. It's the same thing, essentially, but anyway, I'll do the formula that everyone else uses. Every finance, economics, accounting book has. Okay, so what's the general model for this modified internal rate of return? So you have the present value of expenses, and we've explained this before in terms of rent. If you want to set aside money for rent, in the sense that you keep money in some account at some interest rate, and you only withdraw when you need to make rent payments, otherwise you leave the money in. How much money do you need to make that strategy work? You need exactly the present value of rent payments. How much money do you need to set aside in your account to make the strategy work to finance your project? You need the present value of expenses. Okay, that's how much you need to invest right now. So we're thinking we have one kind of, so from that perspective, you have one initial expense period, and that's the present value of expenses. Because you're like with rent, that rent problem we did way back, you're just going to withdraw that when you need to, and otherwise just let it sit. And that's going to be exactly enough to finance the expenses of your project when they are due. So from that perspective, you have one expense, present value of expenses, that accrues n periods of interest at some internal rate of return, J, which we call the modified internal rate of return. Okay. Let's say the project lasts n periods. And what do you get back? Well, again, you're reinvesting all of your revenue into an account earning your reinvestment rate. And so you get back at the end of n periods the future value of revenue at your reinvestment rate. Okay? So again, you started off, and this is not even a simplistic, this is actually the way things work. You start off with that one expense to finance your other expenses, present value of expenses at your cost of capital, because you are investing that into your safe account to finance your other expenses. You start off with that one expense, you end up with the future value of revenue at your reinvestment rate. And so we're setting this up just like we did as a yield problem, as we've done many times, where we have one expense, it accumulates to some number. How is that modeled, and what interest rate is that modeled by? Okay. So what do? You solve for J, very simple algebra. Just divide by the present value of expenses, take the nth root, subtract 1, and we get J. And so this is the formula that is not mentioned in our book, but everyone else uses. And this is this is the formula you're going to use. It gives you the correct answer in terms of the book's answer, yeah. So really, this is just plug and chug. But if I just threw this formula up, it would not make any sense, in my opinion. Okay, and I should also mention what is the relationship between and MER. I just love saying that for some reason. What's the relationship between the internal rate of return and the modified internal rate of return? They are equal in the fairly unrealistic scenario of the financing rate is equal to the reinvestment rate, which is the internal rate of return. Okay, and why is that? I'll just go through this very quickly. Okay, well, let's say J is your internal rate of return. J is your Anyway, okay, having too much fun with that. Okay, so by definition, remember the present value of expenses that's a spectacular X. Okay. So expenses. So this is, again, one way of interpreting the internal rate of return. It's cash in equals cash out. Same thing as saying present value of expenses is present value of revenue. Okay. And of course, that's at your IRR, at rate J. It's not a factorial, it's just emphasizing it's at rate J. Okay, so you can do something kind of silly here, and you can say present value of expenses times 1 plus J to the N. Well, multiply the present value of revenue times 1 plus J to the N, you get the future value of revenue. So it really doesn't help us in any way, shape, or form getting the IRR, internal rate of return, this perspective, but this does tell you that if we're just assuming that one flat internal rate of return everywhere, then we do get the modified internal rate of return. Because this is the J where this is all true. Okay, so, you know, one of the reasons why this is a very nice thing to compute is, well, first of all, you get one single rate. You know, if I was doing complex analysis, we would have nth roots. Everything is real here. You have one real nth root, okay? So yeah, there's only one modified internal rate of return, right? Second, as I clearly explained, it's more practical to invest more conservatively to finance your project than it is to actually take the revenue, which is generally going to be more long-term, and reinvest that. Because, again, you need to make sure that you have a safe investment to pay for the project. All right? So for that reason, it's more realistic to have these two different interest rates. And often, you know, smart people in your company who know a lot about investment, you know they know roughly, or they can figure out roughly what these interest rates are. Okay. Though a lot of people still like to use the internal rate of return to make business decisions, even though this MIRR is more practical. Okay, so I think I'll do an example here and then end, and then I'll do in another video the time-weighted rate of return and the dollar-weighted rate of return. Okay, so find the modified internal rate of return of the following cash flow if the reinvestment rate is 3% and the cost of capital rate is 2%. Also find the internal rate of return. And I should mention, usually, as a matter of practicality, you get a larger internal rate of return than your modified internal rate of return, for the reason that, you know, as I mentioned, I mentioned twice already, you're using usually a smaller interest rate for your cost of capital because you need a safe investment to get your project going. Okay. Now, when you get an internal rate of return, which is usually, you know, higher in the 7, 8, 9, 10%, and you're assuming this lofty investment rate for your you know, for your you know, your investments, for investing to pay for your project, that's pay for your expenses for the project. That's not realistic. It's realistic to have a much lower interest rate to pay for your projects. Okay, so let's and we get that in this case. though it's not that much different. Okay, so fairly plug and chug. Right, so what's the present value of revenue? Sorry, what's the present value of expenses here? We have your three expenses at minus 10,000. So, and the cost of capital is 2%. Sorry about that. That was a little weird. Right, so it's 10,083.02, which is 28,838.83. Okay. Now the future value of revenue at 3% is going to be 5,000 S8.03. So maybe it's more realistic to be able to reinvest your revenue at a higher interest rate, but anyway. Right, so that's going to be 44,461.68. So, right, so you plug and chug into your MIRR formula, and you get 4.424%. So I should mention, this is maybe a good example of when these two rates are close, your MIRR is going to be not that far off from the internal rate of return. It's just in the more practical situation, often more practical of, when you have a higher reinvestment rate, then your modified internal rate of return is going to be lower than your internal rate of return, and it's going to be more realistic. Okay, on the other hand, your internal rate of return, like I said, it's fairly close because these two rates are not that far off. And that is 5.4953%. I'll just go real quickly. Again, overdoing that. Okay, so cash flow. Okay, so right, so you have 10,000 is your initial. Enter. Okay, enter. Okay, then you have two 10,000s. Well, let's just enter it. It's weird. Okay, so let me enter this again. Okay, so 10,000. Enter. Okay, then we have another 10,000. You can do the frequency. Let's just do 10,000 a third time. It doesn't save me any time. Yeah, sorry. When you don't enter anything in your cache, it says the frequency is 0. That kind of threw me off. It should not throw you off. Okay, next up is 5,000, and that's repeated. Let's be a little careful here. So 10 to 3 is going to be 8. It's not 7. 3, 4, 5, 6, 7, 8, 9, 10. Again, I don't think there shall be shame if one uses your own hands. So I think that's tricky, getting these numbers right. That's just my opinion. Okay, IRR, compute. What did I do wrong? Let's check out the cash flow. Quick. So 10,000, 10,000, 10,000. Whoops, that was weird. Thought I entered 5,000. Maybe I didn't hit the enter button. So if you get an error, just go back to your cash flow and double check. Don't panic. Okay, yeah. I must not have hit enter for the 5,000. You're probably going to make a stupid mistake like that, especially on exam event. Don't panic.